Hello, before watching my video, allow me to introduce myself. My name is Kalvyn Pangemanan and my name is 2410110300005 and I'm from Faculty of Mathematics and Natural Science, Department of Mathematics, Class A. Please enjoy the video.
Computers are sophisticated devices that rely on a combination of hardware and software to perform a wide range of tasks. They communicate through various languages, from low-level machine language to high-level programming languages, each serving different purposes and enabling developers to create diverse applications. Understanding these languages and how computers operate is essential for anyone looking to work in technology, software development, or related fields. In summary, when you run a program on a computer, it begins with high-level code that gets translated into machine code. Performing computations in the ALU, transistors enable the fundamental operations that make programming possible, allowing computers to execute complex tasks efficiently. A transistor is defined as a semiconductor device used to amplify or switch electronic signals. The principle of a transistor is based on its ability to control the flow of electrical current. A transistor is a semiconductor device that can act as a switch or an amplifier. Here's a brief overview of how it works. Structure: transistors are made of semiconductor materials, typically silicon. They have three regions: the emitter, the base, and the collector. Depending on their configuration, they can be classified as either NPN or PNP transistors. Operation: NPN transistor. In an NPN transistor, a small current flowing from the base to the emitter allows a much larger current to flow from the collector to the emitter. The base current controls the collector current. PNP transistor. In a PNP transistor, a small current leaving the base allows a larger current to flow from the emitter to the collector. Control mechanism. The key principle is that a small input current, in the base, can control a larger output current, from collector to emitter. This property makes transistors useful for amplification and switching. Applications: transistors are fundamental components in modern electronics, used in everything from computers to radios and amplifiers, enabling the development of integrated circuits and various electronic devices. In summary, the transistor acts as a gate or switch for electrical signals, allowing for the manipulation and amplification of those signals in electronic circuits. A logic gate is an electronic circuit designed by using electronic components like diodes, transistors, resistors, and more. As the name implies, a logic gate is designed to perform logical operations in digital systems like computers. There are three basic logic gates: 1. AND gate, 2. OR gate, 3. NOT gate. AND gate. In digital electronics, the AND gate is one of the basic logic gate that performs the logical multiplication of inputs applied to it. It generates a high or logic 1 output only when all the inputs applied to it are high or logic 1. Otherwise, the output of the AND gate is low or logic 0. Properties of AND gate. The following are two main properties of the AND gate. AND gate can accept two or more than two input values at a time. When all of the inputs are logic 1, the output of this gate is logic 1. The operation of an AND gate is described by a mathematical expression, which is called the Boolean expression of the AND gate. OR gate. In digital electronics, there is a type of basic logic gate which produces a low or logic 0 output only when its all inputs are low or logic 0. For all other input combinations, the output of the OR gate is high or logic 1. This logic gate is termed as OR gate. An OR gate can be designed to have two or more inputs but only one output. The primary function of the OR gate is to perform the logical sum operation. Properties of OR gate. An OR gate have the following two properties. It can have two or more input lines at a time. When all of the inputs to the OR gate are low or logic 0, the output of it is low or logic 0. The operation of an OR gate can be mathematically described through a mathematical expression called Boolean expression of the OR gate. NOT gate. In digital electronics, the NOT gate is another basic logic gate used to perform complement of an input signal applied to it. It takes only one input and one output. The output of the NOT gate is complement of the input applied to it. Therefore, if we apply low or logic 0 output to the NOT gate, it gives a high or logic 1 output and vice versa. The NOT gate is also known as inverter, as it performs the inversion operation. Properties of NOT gate. The output of a NOT gate is complement or inverse of the input applied to it. NOT gate takes only one output.